Okay, so let us start with the first question of a bit manipulation. Let us read the question first. So we have been given a non-empty array of integers nums where every element appears twice except for one. We need to find that single one. And what is the other thing given? That we must implement a solution with a linear time complexity and use only constant extra space. So if you see in the first test case, there are 2 times 2 and 1 is it present exactly 1. So we need to return the element which is present exactly once, right? So here 1 is the answer. Similarly, in this case, you can see the 4 is the answer, and here this one is just present 1, so that is the 1 is the answer, right? So how many approaches are there that we can do this question? I will not show the code for the brute force. We will just discuss the approach and then we'll do the code for the optimized one, right? So first approach definitely would be that in O of n square and O of 1, that we count the occurrences for each and every element, right? We have a for loop going from I equals to 0 to I less than n, right? I plus plus. And then again for this, you go for j equals to I plus 1 to j less than n and j plus plus. So for each and every element, you maintain a count. And once you see if the count is greater than 1, then definitely you need to break from that loop and continue with the another element, correct? Okay, so the another approach method 2, which takes O of n as time constant, O of n as space, is the hash map. So hash map is nothing but you maintain a key value pair, right? So key would be nothing but the array of I, right? And this value would be nothing but frequency of array of I. And then you iterate in your hash map whenever uh, at once if you find the value equals to 1, then definitely the key, that particular key, would be your answer. Now the third and the efficient approach is O of n, the time constant O of 1 as the space. So this is what we need here for this particular question. So this is based on the fact, or this is based on the logic of bitwise XOR operator. So what a XOR operator is, so when you have two different bits, the value is returned as 1, and if you have the same bits, then the value is 0, correct? So we need to leverage this particular what is it, functionality, and to solve this question. So in the given array elements, let's say you were having 2 1 2 1 and 4, right? So that means if that means 2 XOR 2 will give you the resultant as 0, and then again 1 XOR 1 will give you as 0. So the final XOR 0 XOR 0 will give you 0, right? And then you will XOR with the last element remaining, that is 4, and you will get a 4 here, because if the bits are different, if the values are different, you get the different one, right? 0 XOR 1 gives you 1, 1 XOR 0 gives you 1. So that's the entire logic. So we just have to run a for loop and do the XOR of all the elements present there, and then we can get the answer. Let us see the code once. Okay, so that's the code in Java. So we have an answer which is pointing to the first element of the array, and then we are running a for loop for equals to I till less than the last element. Then we are just returning the XOR of all the elements. That's it. So what is the time and space complexity again? It is O of n and O of 1 as space. Okay, so our solution got submitted. So yeah, that was the most optimized one, and we will just see the optimized solution, and we'll just discuss the brute force for all the questions present in the sheet, right? So yeah, the same code would be there in the C++ as well, just that nums.length will be converted to nums.size and everything will go as it is, right? So again, for the source code, you can start and fork my DSL repository together with the source code. The link would be in the description, and let us meet again in the tomorrow's video. Till then, keep learning, keep going, bye-bye, and take care.